There you go. Sorry about that online. We were just talking about the career fair, and if you make your way over there today if you can, with with your resume or whatever, even if there's nobody there. At least I think that they do offer services like you can get a headshot or something, or no. Well, like like a professional photo or something. Okay. Well, you have to dress up for it, right? Anyway, so today we're starting on the next topic, which is MySQL databases in MySQL. And really quick here, I just want to motivate it. Hopefully it should be self-evident with the work that you're doing right now with CSV files. That CSV files are not at all, they're called flat files generally. They're not at all sufficient for data management. Here's a typical flat file where you've got, say, repetition of data, right? For an enrollment system here, we're repeating the course and the course name over and over and over again, even though it's one course, it's the same course. We also have formatting issues here because we've got Tom Waits, Tom space Waits, capitalized properly. And then here we've got lowercase, all lowercase and then Waits, comma, Tom, right? We've got, even though they're the same person with the same MUID here. We've got records here that are placeholder records, right, with empty strings, just so that we can have yet another email over here. Ooh, well, I don't know why it's slanted like that, but whatever. And then we do the same thing over here, but we do it in a different way, right? There's no consistency here. We use the keyword, or we use the string none, and then a built-in null value to indicate that there is no course name, right? That's not tenable, right? We've got repetition of data, we've got formatting issues, we've got consistency issues, we've got all of these issues, but more, right? We've got integrity issues. If you've got repetition of data, then you've got a potential failure point, an anomaly, right? For example, the multiple different spellings of Tom Waits, or representations of Tom Waits. You have organizational problems because it's not sorted. If you wanted to run a report and pull the course listings for every course, you'd have to sort it by courses and then pull out what you're looking for, or basically you'd have to process the entire file. Right? If you wanted a different report for one individual, you'd have to process the entire file. And if this is being done synchronously, in other words, no multi-threaded or multi-user capability, then you're waiting a long time. And what we mean by that is, take a typical Word file. You're editing your Word file there, right? And then you say, okay, well, I don't want this anymore. I'll go ahead and try, when it's still open, try dragging that file to the garbage or the recycle bin or whatever it is. It will not let you because of what's called a file lock. One program is using it, another program can't be using it at the same time, right? For consumer-facing stuff like Word or word processors or stuff like that, that makes sense. But for a huge database, right? We cannot have, say that we're serving like 1 million users or something. We can't have each of them going one at a time, right? We need multi-threaded, multi-user capability. And that doesn't happen with one file, right? There's also no security. Right? If you have access to this one file, right, then you have access to every single record. Right? There's no way for me to stop you from getting access to this file. And there's no way for me to make it fine-grained so that I can say that, well, you can have access to your course, but not to everybody else's course, right? That's called a view in a database. That's called, I can give you access to that table over there, but not that table over there. That's fine-grained security. What I could also give you is read-only access. Yes, you can go ahead and produce a report of all these students over here, but you can't just go ahead and add or drop, students from your course. That's a view, right? A read-only view of the database that doesn't give you write access to it, right? All of these problems and more are solved by an RDBMS. RDBMS being a relational database management system. RDBM, DB for short, or however you want to put it. It goes back to 1970. So it's actually kind of recent, actually, when you really think about it. It's really obvious, but the mathematics goes back hundreds of years before that. You're all taking 235 right now, 235H maybe. What is your current topic? Sets, okay. Eventually you're going to get to relations on a set. which is, now you've talked about sets, so I assume that you've talked about Cartesian products. If I have a set A, right, equals A, or let's say A, B, and C, right? There we go. Let me go into full mode here, there. There's my first set. Oh, well, that's not how we write a set, sorry. I need to escape these. There. There's my first set. If I did something like this, A times B, or A times A, excuse me. What is that equal to? Have we seen this notation here? Cross product, Cartesian product, right? In fact, it's what you've been doing all your life with the XY axis. What is that? It's a Cartesian product of the real numbers, right? X, Y. These are pairs, but since it's only A and B, it's A, right? A paired with itself, A paired with B, A paired with C. What else is in there? B, A, B, B, right? And B, C, right? And then all the C's as well, right? Dot, dot, dot. I won't go all over, but a relation is a subset of that, right? So R is a subset equal. There we go. A relation is a subset of that Cartesian product. With respect to tables, and here's our first database that we're going to be working with today. It's a video game database, looks familiar. Well, I did a demonstration of this flat file version in the first few weeks of this course. If I've got separate data out into multiple tables, I need to eventually bring these tables back together. The way I do that is through what's called a join, a Cartesian join, a cross product, right? And then I'm only interested in a subset of that data, and that's where a relation comes in. R stands for relation. Eventually, you'll cover that in 235, and just know that, hey, a relation, that's exactly what a database is, a relational database system is. Right? All due to Edgar Codd at IBM in the late 60s, early 70s. Right? The key aspects are that data is stored in tables. Right? Tables have columns. Columns, these are pieces of data, right? And rows, which are records. Columns have a type, right? So for example, come back over here to the flat file. There's nothing to stop me from setting hello to an NUID, which is not a valid number. So what I can do in a database system is I can say that column is an integer. It will only allow integers to get into that column. That column is a double. It'll only allow double values. That column is a string. It'll only allow string values. Right? In other words, we have strong typing just like we do in any programming language. Right? Each row corresponds to a single record. It's kind of like an Excel file where you've got columns and rows. Don't think of it like that, though. Think of it like it is. It's a table. We've got columns, pieces of data. Each row corresponds to a record in that table. Okay? Records in different tables are related through what are called records. Unique records in a table are uniquely identified with a primary key, or PK for short. Right, PK. For example, over here in my diagram, this is an ER diagram. You'll be producing something like this eventually for your database. Each table has an ID associated with it. So for the publisher table there, we've got a publisher ID. For the game table, we've got a game ID. For the platform table, we've got a platform ID. If you zoom in really far, what does this little yellow thing look like? A key, right? That's what it's supposed to be, right? But it's kind of a potato quality kind of image, so it's not a high-res key, right? But records in tables are uniquely identified with primary keys. Right? Records in different tables are related to each other through what are called foreign keys, or in this case, FK for short. For example, the game table and the publisher table, this little arrow right here, right, this little link between them, is denoting a relationship between these two tables. Relational database management system, relations. That one publisher can publish many games. That's what this chicken foot is, right? We call it a chicken foot, right? Why? Chickens, how many toes do chickens have? 3. So if you look at a chicken's foot, it spreads out like this. That's a chicken foot right there. This is one record to many records over here. This models the idea that one publisher, I think we used Naughty Dog in the last section, publishes multiple different games. Uncharted, Last of Us, Crash Bandicoot. Apparently, I did not know that. Right? Anyway, I'm going to solicit you for current games when we go through this demonstration. Pick a different publisher, right? So that we can have variety here. Anyway, so just look at this table, the game table. Can a game exist without a publisher? And vice versa, can a publisher exist without a game? So can a publisher exist without a game, first of all? What does a publisher need to exist? An ID and a name. And before we answer the question, what is this thing right here? Varchar 255. What do you think varchar is short for? Var, variable. Char, character, right? So variable character. What do you think this is? A string. Right? A string of up to 255 characters. If you have a string that's more than publisher name that's more than 255 characters, the data gets truncated. It gets cut off, and only 255 characters are supported. By default, they're going to be ASCII. You can set up your database to support Unicode. Right? Anyway, can a publisher exist without a game? Certainly. Right? But can a game exist without a publisher? No, it's right there. It needs a publisher ID to survive. This is a parent-child relationship. Anytime that you have a many-to-one or a one-to-many relationship, you should orient it top to bottom, conceptually at least. And then ask yourself, can a child exist without a parent? No, they came from somewhere. Right? But can a parent exist without a child? Yeah. Right? There are plenty of childless people out there. Right? Okay? So those are our basic types of relationships. There's a many-to-one relationship, a one-to-many relationship, which is just the opposite, right? A one-to-many relationship is that one record in a table A may be related to many records in table B, including 0. I could have a publisher that doesn't have any games published yet, a brand new publisher, right? Or my database just doesn't have the data from them. Right? A many-to-one relationship is just the reverse, right? It's the same, but from the perspective of B, excuse me. And then finally, there's a many-to-many relationship. One record in table A can be associated or related to many records in table B. Where do we have a many-to-many relationship here? One game can appear on multiple platforms. One platform can have multiple games, otherwise it'd be a pretty crappy platform. Right? Just one game. So we've got what's called a join table in between modeling that idea. Right? So we've got a foreign key here, game ID, that relates back to the game table. We've got a platform ID that relates back to the platform table, modeling the fact that Crash Bandicoot is available on the Super Nintendo, whatever it was. Right? I don't know, was it on the Super Nintendo? And nobody knows. PS1, was it PS1? Okay. I thought it was older than that, but no. The only reason that they said Crash Bandicoot is because apparently in Last of Us, you can actually play it as a mini game inside. Like you could find a. Oh no, we don't know. They said they said so because it was made by the same publisher, so they just put the game within a game. Right? Do we not have many gamers here? No. Okay. Anyway, you can have another type of relationship, a one-to-one relation, right? Where you've got one record in one table is related to another record in the other table. The question is why, right? If there is only a one-to-one record, why isn't it in the same table, right? So be very suspicious of this, right? Suspicious of this. Right? Probably don't want to do it. We're going to use that video game database, and we're going to introduce basic CRUD. Right? CRUD stands for Create, Retrieve, Update, and Destroy. These are the 4 basic things that you can do with data structures, the 4 basic things that you can do with an application, basically anywhere that you're storing data. You have to have a way of putting stuff in. You have to have a way of pulling stuff out, retrieving. You have to have a way of retrieving something, say, okay, this needs to be changed, putting it back in. You need a way of permanently removing stuff from that database or that table or that data structure or whatever. These are the 4 basic things. Okay? We're going to get through create, update, and destroy, but retrieve gets really fancy because of that relational nature of the data. Okay? To get started, usually the way that you get started is, I demonstrated, MySQL Workbench the other day. Make sure that you download it. Make sure that you get your login or whatever. I'm just going to go ahead and immediately jump through this. This is a script that creates all those tables that you saw in this diagram and inserts a bunch of test data. For example, Portal, Portal 2, Katamari Damacy, et cetera, et cetera. I'm going to go ahead and execute this entire script here. Ignore, ignore. And then we're going to start fresh. So as a preview of retrieve, let's go ahead and select everything from game and look and see what games we've got in here. Big enough? In the back? Okay. Let's go ahead and execute this. Unfortunately, I cannot zoom in on the results, but you'll eventually have results that look like this. It looks like an Excel file. It looks like a table. You can sort and resort. You can actually select. You can probably just select all this, copy it, and then take it into Excel if you wanted to. You can change stuff, right? Change that name to foo, right? Change that to bar, right? And if you close this, it's going to ask you, do you want to apply those changes? No, I don't want to. I'm going to do that through SQL, not through MySQL Workbench. But you saw the games we have. We have about 20 games. We've got game IDs, and you'll note here that what is it about the game IDs here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 20. They're contiguous. They're unique. I let the database handle that for me. I don't want to do key management myself because that's why we use these tools. That's why we use relational database management systems. It takes care of key management for me. Imagine if I didn't. I'd have to go to the table, and I want to insert a new game here. Okay, is game ID 5 taken? Yeah. Is game ID 13 taken? Yeah. Is game ID 20 taken? Yeah. Just keep asking this question over and over and over again until you get a yes. 21, okay, there you go, right? Don't do that. Let the database take care of it for you. We've also got publisher IDs. Publisher ID 6, who published GTA, all the GTA series? Yep, from publisher. We can go ahead and take a look at the publishers. Who is publisher ID 6? Rockstar Games. Right? That's associated with another table, though. Select everything from platform. Oops. Everything from platform. Spell it correctly. There we go. And this will, out me as when my video game days ended. Right? I assure you, though, we have a PC gamer. Oh, so we have PC along with an Index and an Oculus. Oh, and a Switch, right? But that's for my kids. I don't play any of that stuff. Right? I stopped playing. I did play the Switch for Splatoon 1 and 2. I can't waste my time going back to 3. Right? All right, so my gaming days basically ended with PS3. Actually, no, I didn't even own a PS3. I still own an Xbox 360. It's still going, right? But I owned a PS2, but I never owned a PS3. Right? Anyway, so there's our initial data. Now let's go ahead and focus on the CRUD, the C, the U, and the D, the CUD, right? Create. We need a way of getting records in there to begin with in order to start processing them. So let's insert a new game, or a new game record. ... Give me a game. A current game. Other than Last of Us and Outlander, or what was Outsourced or something, whatever it was. Red Dead Redemption? Okay. That's current? Red Dead, is that current even? So we're going to insert into game. Actually, that's Rockstar Games too, right? All right, so give me something else. Uncharted is what they're, that's the one that they did. That, there's no games out right now?
Sons of the Forest came out yesterday.
What's Sons of the Forest?
Yeah, it's like a survival game.
Okay, insert into game, the game name, values, and you said what, Sons?
Sons of the Forest.
Sons of the Forest. Did I spell that right? Okay, there we go. So let me go ahead and try to do that. Now you'll note down here that, let me go ahead and clear this, right? That I got a red, a red X here. It didn't work. Why? Field parameter publisher ID doesn't have a value. Remember, for a game to exist, what do we need? We need a name and we need a publisher ID. So what do we need to do before we insert that new game? Insert the publisher. Who published it?
New Night, for instance.
Insert into publisher, name, values, new night,
Yeah.
like that,
Night as in,
NIGHT,
that's right.
all one word?
Mm-hmm.
Okay, there we go. So now before I insert this, that's all that's needed because this primary key right here will be automatically generated and automatically incremented. If you have a good, well-designed database, it'll do it for you. Right? You don't have to do it like that. You can do it like this instead. Publisher ID, name, and I'll go ahead and give it a value here. One that I know that will be valid, 100. In general, you want to prefer this, something like this, and let it generate the ID for you. For test data, right, this is okay for test data. Why is this okay for test data? Because eventually I'm going to put in a publisher ID here, and I want to be able to hard code that value here for test data. Right? That's exactly what I did in the video game database. I hard coded all my primary keys and foreign keys so I could use them as foreign keys. Right? Let's go ahead and execute this. Let's take a look at the green check mark. It worked. Let's take a look at all the publishers now. New Night 100. That's now in the database. Now I can go ahead and insert this game and associate it with New Night over there. And you see that it also has a green check mark. And so I've got that successful as well. 21, Sons of the Forest, 1R? Okay. Forest, 1R? Yes? Okay. I don't know if it is or not. Anyway, there we go. We've got some data in there. Now, just what platform is it on? Is it PC?
Yeah.
Okay. PC only? All right, and let's go ahead and go with what's the platform there? All right. So we've got a PC is platform number 7. So it already exists. So let's insert into how am I going to make that game available on that platform? I need to insert a record here in the availability table. In other words, I need the game ID and the platform ID and then the year that it was published. So let's insert into availability the game ID, the platform ID, and the year that it was published. Publish year, or what was it? Publish year. Right. Values, availability. I don't know why it's complaining about that, but let's go ahead and go into the next line. Generally, white space doesn't matter, so break up long lines here. Right. I want a game ID. Well, what game was just inserted? I can go ahead and look that up. Sons of the Forest, number 21. So I could put in and hard code that value 21 here. Platform was, what did we say, 6? Double check here. PC is, 7, NES. Is it available on the Nintendo? And publish year is 2023, I assume. All right, there we go. If you don't want to hard code these values, you can also use a nested query to find the key values. So I don't want to hard code 21 here. Instead, what I'll do is I will make another query here inside parentheses and select the game ID from game where name is equal to Sons of the Forest. There we go. And what that's going to do is it's going to execute that inside that nested query, go out, get the game ID from that game, and replace it for me so that I don't have to hard code those values. For test data, go ahead and hard code all you want. Yeah,
What happens if multiple game IDs have the same?
it will fail. Right. So let's go ahead and insert it for now. There we go. Yay. Let me go ahead and come back up here. And what's to stop me from doing this again? Nothing. Green checkbox. Let's check out what the game table looks like now. Sons of the Forest, Sons of the Forest. Right. I've got 2 records here. It's okay because one is 21 and one is 22. Right. If you want to, if you need to, you can put additional constraints to say that this name right here for the publisher should be unique. This game title should be unique. Right? And I don't know if are there any 2 games that have the exact same title that were published, widely different? I don't know. It depends on your business rules, right? If you don't want that to happen, then you need to put in constraints in your database to forbid that. If you do say, oh, okay, well, that could probably happen. For example, there are many John Smiths out there, right? You probably don't want to have that kind of constraint, right? But yeah, you can put in constraints to do that. Now, when I do that down here, unfortunately, this is also going to fail now. Why? Because it comes back with 2 records. There are 2 records with Sons of Forest, 21, 22, and so I can't do anything with that. And it tell you that. Subquery returns more than 1 row, right? Very nice descriptive problem right there, right? Okay. So let's go ahead and fix that. Right? So I can create records. Let's go ahead and destroy records. I don't want that duplicate Sons of the Forest. It's a survival game, like a gritty survival game, or is it a cartoony survival game? What?
It's pretty great.
Oh, pretty gritty, okay. All right, so let's go ahead and delete from game. And let's go ahead and do it like that. Now, if you just read that by itself, what do you think would happen? Are you deleting one particular game? Or those 2 games over there, or those 3 games over there, right? Nope. You're deleting every single record from that table. You're not deleting the table. To delete a table, you would have to drop a table. But we are deleting every single record from that table. That's bad. That's why it doesn't let us do that. If you can read this. You are using safe update mode, and you tried to update a table without a where clause. I'm not going to let you do that. I'm going to save you from yourself. Right? So you need to put in a where clause here. Where name is equal to Sons of the Forest. But is that really what I want? Do I want to delete every game with that title? Nope. So let's change this again. Game ID, I told you it was 21 and 22. So let's delete that second superfluous one. Green check mark. Why? Because you were only deleting 1 record. Right? If you did this, greater than 0, I do believe that it would let you do this because, yeah, you're using a where clause. You must know what you're doing, right? But what will that end up doing? Deleting every single record. Nope, nope, nope. Right? Deleting a record that does not exist is okay. Green check mark. It just tells you that 0 rows are affected. Right? 1 row was affected before. Now 0 rows are affected. And we can see that that game is now gone. We only have the original number 21. Okay. That is inserting records, updating records. Does that publisher have another game? Yes?
Well, there's the Forest, which they...
The Forest.
Yeah.
All right. Oops, I don't want to save. The Forest. There we go. There. I misspelled it, didn't I? Oopsie. Right? That gets us into the update. That is the one part of CRUD where the keyword matches the acronym, update, update. All the others, create is insert, retrieve is select, update is update, and destroy is delete. Right? Even though they're both D words. Right? So let's go ahead and fix that. Fix the spelling of forest to forest. So let me go ahead and update game, set name equal to the forest. There we go. Now, once again, read that. Update game set name equal to forest. If I successfully executed this, what's going to happen to every single record in the table? All of them will have the same name. Error, safe mode. It's saving you from doing this. If you were to do this from the command line, there is no safe mode by default. When you go to program this stuff using JDBC, there is no safe mode by default. Right? It assumes that you know what you're doing. MySQL Workbench here is being nice about it and says and assumes that we don't know what we're doing, and so is saving us from ourselves. You can set safe mode to be false, and then shut it off. Right? Something like that. I'm not going to do that because I like it saving me from myself. So let's put in a where clause here. Where game ID is equal to, what was that game? 22, or no, it's now 23. Why? Because we had a record of 22, we deleted it, and so it's just going to go, it's not going to go back and say, oh, I can save on a few numbers here, right? The next available one was 23, and that's why it used 23. Okay? 23. Execute that, and let's look at the games again. Now it has been spelled correctly, the forest. Right? So create, retrieve, update, and destroy. Retrieval is what we're going to be looking at next. Any questions so far? I don't know why we breezed through this. I mean, this is where we got to in the last section. I don't know. Maybe I was going way slower. Right? But we breezed through that. Right? Insert, delete, et cetera, et cetera. No? Any questions? Yeah, go ahead. Good question. So the way that I've been running this so far is by quick keys. So it's a Mac, Command Enter. Let me go with something safer here. Command Enter will execute whatever query you are currently, the cursor is on. Right? If you want to run the entire script from top to bottom, then that is going to be Shift Command Enter. And I don't want to do that here because I don't want to repeat everything. Those are the quick keys. But if you come up here, execute the selected portion of the script or everything if there's no selection. So you can go ahead and click that button instead. Execute the statement, come on, under the keyboard cursor. So that's the difference between these two, and that's the difference between the quick keys. Right. You can save this as a .sql file, untitled.sql somewhere on your machine, and come back to it at a later date. Right. Yeah?
So what is this code editing?
It's just a script, it's like a Python script here,
Okay.
right? And whatever you execute, it gets executed.
Where's the data coming from?
It's on the CSE server. So let me go ahead and close this out. And close this out. There we go. So you'll set up your connection, right? And your again, the host name would be cse.unl.edu. Once you've got your login, same login as the CSE login, then you'll open it up and it'll look like this initially. Oh crap, did I lose everything? Oh well. Apparently I did. Oh, that's all right. It's on. I've got an example from the other class, right, that I'll post. There it's going to be Uncharted and Last of Us, but same exact stuff. Now to create that database, I had over here, I wrote all of this stuff, right? This is what I executed right at the beginning. This is what your scripts are going to look like eventually when you create your database and create the test data. First of all, use your login. That's the only one that you can use. You can't use Joe's login. You can't use whatever. You only have access to the database named after your login. Right? Eventually, after we're done with CRUD, we're going to design our own tables. These are dropping the tables if they exist, because you can't because it's going to want to recreate them. We'll create the publisher table, insert a bunch of publisher data. Again, this is just test data, so I hard-coded all these values, right? All these primary keys right here. I made sure that it worked by selecting all the publishers. I created the platform table. I created a bunch of platform data. I created the game table. Created a bunch of game data, right? Mapping it back to the publishers. Note here that I intentionally made it incorrect so that I could correct it later on. Right? Mega Man 4 was published by Capcom. I think it's published by Eidos here, right? The availability table, and then I made things available. And guess what I was doing along the way? Making notes to myself. Right? How was I doing? You can do it like this, space, right? That'll work. Some systems require that you use hashes. If you use both, like I've done here, then you take care of all eventualities. Right? These are just comments here. Okay. All right, I don't want to save that, but then I did. That's all I did. Right. When you get not this week, but next week when you do the albums database, we give you a file that looks like this. You just cut, paste, execute everything. Now, again, executing everything is going to be Shift, Command, Enter on a Mac. I assume Shift, Alt, Enter on a Windows machine. Right. I'm not sure. But there you go. This is MySQL Workbench. If you want to use something else, that's fine too. The reason I'm using this is the price is right. It's free. Okay. All right. This is an ER diagram, an entity relation diagram. I auto-generated this with MySQL Workbench. Not this week, probably after spring break, when you do your design document draft for your database, we're looking for something like this. Just sketch it out. If you wanted to go ahead and implement it all right away and then just generate this, that's fine too. But I wouldn't do that. Right? Sketch it out. We can give you feedback. Eventually, after you're done implementing your database, generate something that looks like this. Right? And again, it's a one-to-many relationship. We've got a bunch of keys. We've got a bunch of values here. Okay. All right. Any questions on insert, update, delete? Let me show you another trick then. Come on. There we go. Insert multiple records at once. So let's go ahead and insert into game values. Insert into the game table values, game or name, and actually let's just do publisher because that'll be easier. Publisher, name, values. Sorry, there we go. Now, if I just wanted one publisher, what was the publisher's name? What? New Night. There we go. And you want to insert multiple records, you can do that. Usually I go to, again, white space doesn't matter, so I try to break up long lines here. Naughty Dog. Right. There we go. Give me another publisher. Sorry. Say what? Oh, Rockstar's already in there though, remember? Blizzard's already in there too. Something that's not old. Who publishes like NBA 2K and stuff like that? Is that still a game series? EA? All right, EA Sports. All right, we'll just go EA Sports here or something, right? There. I'm going to execute this one query. All three of those will now be in there. So select everything from publisher. Publisher, there we go. And we see New Night, Naughty Dog, and EA Sports. And that's just a way that you can, do multiple records at the same time, right? Rather than having to repeat the query over and over again. Some notes here that SQL is a declarative programming language, which is part of a functional style programming languages. It declares what it is. So think about Excel, because most of you have some Excel experience. If I want to say that this cell, the value of this cell right here is the sum of these cells over here, I am declaring it to be so. This is in contrast to, say, a procedural style, where how would you have to do this in, say, C or Java? You'd have to do a for loop. Here's my total, 0. For the first record, add it. For the second record, add it, add it, add it, add it. It's defining a procedure, an algorithm for going about and making those sums. But in Excel, if you say this is equal to sum of these categories over here, you're not saying how it gets done, right? You're declaring that it is what it is. And this is a declarative style programming language, where we're declaring insert into publisher these values. right? Select from everything from the publisher. This star here is called a wildcard, right? So star is a wildcard. It means include all columns in the query. That's what where we'll start on Friday, right? But otherwise, it's bad practice to do that generally. But since I'm just in an IDE here, it's perfectly fine, right? If you only wanted to select one of those columns, you can do that too. Select name from publisher. Now I'm not getting both of those columns, I'm just getting one of those columns. That's a preview of Friday. What other tricks did I want to show? Oh, so other things that I wanted to point out to you though is how do I denote strings? Double quotes. You can do single quotes if you want, as long as you are consistent about it and you end it with a single quote. New Knights Publishing. If you use single quotes though, what happens? You can't use single quotes inside. The solution to that is escape it, and now you're back. Or the solution that I prefer is use double quotes. Now, the problem is that you can't use double quotes in your columns, but how often are you going to use double quotes anyway? Right? New Knights Publishing, and again, that's not a real name, but you get the idea. What is at the end of every line? Semicolon, right? C-style syntax, right? We call it C-style syntax, but it predates that. I think Fortran actually gets the credit for that. Or maybe it's COBOL, I forget. Ending things with semicolons. Commas for lists of stuff. Each one of these things is a tuple, right? Yeah. Very, very old school. Right? So you could rewrite this as, let's go ahead and cut and paste this, I guess. You could do something like this. Oops, I don't want to save. Insert into publisher name values. In other words, very, very old school folks will use all uppercase letters for all of these, the MySQL syntax, right? All the reserved words, like insert into and then values. Publisher and name, those are case sensitive. Capital P publisher does not exist, right? If I tried to do something like this, oops, capital P publisher. That does not match the table name, okay? These, however, are case insensitive. Now, why do I call this very old school? Imagine back Edgar Cod in the 1970s. Did they have color monitors back then? Nope, they had green screen monitors. So one technique that they used was, okay, well, we need to be able to make our code readable, so we'll go ahead and make all of the keywords into uppercase so that we know that this is this is a table name. These things are SQL syntax. Do we live in the 1970s anymore? No, we've got nice color monitors. We've got nice syntax highlighting. Right? Are you going to go ahead and kill your pinky by holding it down on the shift button every single time you type everything? Don't. Save your pinky. Use all lowercase instead. Right? And now it's blue, 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 blue everywhere. Right? If you misspell it, it'll tell you. Right? Red, no. Right? So don't go old school. Again, you'll see people using old school style like this just because they got in the habit of some sort, at some point, neglecting the fact that they've got arthritis in their little pinkies now because of this. Right? I'm not going to do that. Okay. The one time that I would do that is in JDBC code because there you don't have syntax highlighting. When you embed SQL code within Java code, then it gets messy and unreadable. Right. Any questions? No? Okay. Then we'll go ahead and pick it up there on Friday.